So far, you should have a good knowledge about how to write a GPU program and how to tune the GPU program to achieve the best performance. Starting from this video, we're going to introduce the ROCm libraries. So why we want to use libraries? Because it's very convenient. You can reuse the code that is written by someone else. There are a lot of GPU libraries that already implemented functions that is commonly used. So you don't need to deal with the low-level GPU code, and you don't really have to optimize the performance. You don't have to debug the code. And also the performance of libraries, especially first-party ROCm libraries, are expected to be very high. It's highly optimized by AMD developers, and AMD has full-time developers to optimize the performance for commonly used algorithms like matrix-to-matrix multiplication. And after all, the functionality is reasonable. It's very unlikely that these first-party libraries to have bugs. So there are a lot of libraries that are available. For example, we have BLAS, which provides linear algebra operations. We have ROCsparse, which provides linear algebra operations for sparse data formats. We have fast Fourier transform, we have random number generator, we have equation solver, we have ROCprime, which provides the parallel primitives so that you don't really need to re-implement a lot of commonly used code. And also we have RCCL, which stands for Radian Collective Communication Library. And finally, we have AMD, which is a library that implements deep neural network layers. In these videos, we're not going to introduce RCCL and AMD because we're going to introduce them in later sections. We're also not going to introduce ROC Solver and ROCprime because they're only for advanced users. But in this section, we're going to focus on the first 4 libraries. Sometimes you may see heap libraries and ROCm libraries. So you may say heap BLAS and ROC BLAS, heap sparse and ROC sparse, heap solver and ROC solver. So what are the differences? Why AMD provides both heap libraries and ROC libraries? This is because ROC libraries are implemented for AMD GPUs, but the heap library is just a wrapper for ROC libraries. Heap libraries emphasize portability so that it also wraps the CUDA library so that you can run it also on NVIDIA platforms. But the ROC libraries emphasize native performance, so if you want extreme performance, you probably want to use ROC libraries. According to our profiling result, using heap libraries will actually not add too much overhead, and the performance is basically equivalent, and you get portability if you use heap libraries. These libraries are very similar. If you know how to use ROC libraries, and if you check the heap library documentation, you should be able to write heap libraries without any difficulty. So in this section, we will be focusing on teaching how to use ROC libraries. So we will leave it to the user to learn how to use the heap libraries. In the next video, we're going to start with the ROC BLAS library.